Yes, dear students of 10th standard, I welcome you all in the name of Lord Jesus to listen and understand this lesson. We are discussing about periodic classification of elements in these days, and so far we have learned up to extractive metallurgy of iron. So next topic, alloys. Before move to the next topic, I would like to ask some questions on the periodic classification of elements to check and enhance your understanding level and learning capacity. So in the extractive metallurgy of aluminium, you have learned already. Aluminium is most abundantly obtained in the earth crust, and there are three ores. Out of these three, bauxite is the chief ore. Formula Al2O3 2H2O. And there are two steps in the extraction of aluminium from the bauxite ore. First step is conversion of bauxite into alumina base process. Then second step, electrolytic reduction of alumina by Hall's process. Then the extraction of copper. Copper is obtained in the native state as well as a combined state, and there are three important ores of copper. Out of these three, copper byrite, the sulfide ore of copper, CuFeS2, copper byrite, which is the chief ore of copper. Then there are a few steps to extract the copper from copper byrite. Then next one, extractive metallurgy of iron. It is the second most abundant metal available next to aluminium, and it is highly reactive metal, so always obtained in the form of combined state like oxides, sulfides and carbonate. There are three ores of iron: hematite, magnetite, iron pyrite. Out of these three, hematite, that is oxide ore Fe2O3, which is the chief ore of iron. And here also there are few steps to extract iron from its chief ore. The next one we are going to study now, that is alloys. The topic is alloys. So alloy already have learned in 9th standard also. Alloys are nothing but homogeneous mixtures. Homogeneous means the components are uniformly spread in the solution. We cannot see the components through our naked eye easily. So an alloy is a homogeneous mixture of two or more metals. This is a simple definition. You can note down. An alloy is a homogeneous mixture of two or more metals, but sometimes non-metals also used. Few non-metallic elements also used in the preparation of alloys. The properties of alloys are often different from the components. For example, pure gold. Pure gold is so flexible and elastic in nature, so it cannot be used to prepare the manufacture of jewel, but by the addition of a small percentage of copper with gold, it is going to give more strength and utility to give shapes and designs to prepare the gold jewelry. So addition of copper only enhance the strength and utility to give shape, design, and to prepare the jewels. Next one, amalgam. So an amalgam is an alloy of mercury with the metal. This is the simple definition. The first line, an amalgam is an alloy of mercury with the metal. So mercury, what is the formula of mercury? Hg. Hg. Mercury is mixed with some other elements, metals, to prepare a new type of alloy. These type of alloys are called amalgam. And these alloys are formed using the metallic bonding. Metallic bond, because both are metal. Mercury is metal, the combining element also going to be metal. So metallic bond is developed using the electrostatic force of attraction between the electrons and positively charged ions. So metal amalgam is formed. For example, silver tin amalgam. Silver tin amalgam is used for Tyndall filling. Sometime will be asked in the objective also. What are the components of Tyndall amalgam? Tyndall amalgam. What are the components? Three elements are there: silver, tin, mercury. That is called Tyndall amalgam. Silver, what is the formula of silver? Ag. Tin, Sn. Then mercury, Hg. So silver, tin, and mercury. These are the three components in the Tyndall amalgam, and this amalgam is especially used by the dentists, dental doctors, to fill the cavities and the teeth. Then, reason for alloying. Why we have to do alloy? What is the purpose of alloying? What is the use of alloying? So first point, to modify the appearance and color. So this alloying going to give very fine appearance and changing the color. Then also modify the chemical activity. So normally iron easily reacts with the air in presence of carbon dioxide and moisture. But when iron is alloyed with zinc, iron is alloyed with zinc, zinc will not allow oxygen, carbon dioxide, and water to react with the iron. So the chemical activity is completely changed because of the type of alloying. And third point, to lower the melting point. Melting point will be reduced. Fourth point, to increase hardness and tensile strength. Hardness and tensile strength. That already we have learned. That is a small percentage of copper is added to gold. Then only the making of ornament is possible. The addition of copper only give the hardness and strength to make jewel from the gold. Then to increase the resistance to electricity, and also it helps to resist, and resist means it going to hinder, it going to block the flow of current. That is to increase the resistance of electricity. So these are the few points for alloying, reason for alloying. Then next one, methods of making alloying. There are two methods given in your book. First method, by fusing the metal together. So the metals involved for the alloyings are fused into molten state, fused in the form of liquid, and these liquids are mixed thoroughly to get a new type of alloy, new product. For example, brass is made by melting zinc and copper. Zinc is melted in the molten state. Copper is also melted in the form of molten state. These two are mixed thoroughly to get a new product that is called brass. And the next type of making alloy is compressing the metal with one another. So finely divided metals are compressed by apply more pressure and to get a new product. For example, wood metal. Wood metal is prepared using the alloy of lead, tin, bismuth, and cadmium powder is also fusible alloy. So these are the uh, types of making alloys. Then alloys as solid solution. Alloys can be considered as solid solution because here mostly solids are used. Alloys are nothing but homogeneous mixture of metals. Metals are solids. Metals are solid. So alloys are considered as solid solutions. These solid solutions only going to mix with one another to give you a new product that is called alloy. So it is a solid solution, and here we are going to consider two things because already we learn in the solution. Solutions mean nothing but solution is obtained by the combination of solid with solvent. Solid plus solvent gives solution. Solid plus solvent gives solution. So here there are two things are taken here. The high concentration is solvent. The high concentration component is solvent, and the other one is solid. The other one is solid. For example, if we take brass is a solid solution of zinc in copper. Zinc in copper. So two elements are in the brass. Out of these three, zinc acts as solid and copper acts as solvent. So copper is going to be in more concentration with high percentage, and zinc is going to be less percentage in the brass. That is the meaning. The brass manufacturing, zinc element is less in concentration, less in percentage compared to the copper. Then types of alloys. Based on the presence or absence of iron, alloys are classified. There are two types. When iron is the major proportion means that is called a ferrous alloy. Then iron is not a major proportion, major component means that is non-ferrous. Ferrous means iron. Ferrous alloys contain iron as a major component. So most of the proportions are occupied by iron, and the remainings are going to occupy very little proportion. For example, stainless, that is in the manufacture of stainless steel, nickel steel. So stainless steel we used in the form of vessel in our houses. Most of the vessels are in the form of stainless steel. So in the manufacture of stainless steel, iron is going to be a major component. Iron is going to be a major component. Then the other components are going to be only in less proportion. Then in the non-ferrous alloy, they are not having iron as a major component. For example, aluminum alloy, copper alloy. So my dear students, there are two types of alloys. The types of alloys are classified based on the presence or absence of iron. When iron is a major component, that is called ferrous alloy. Example, stainless steel. When iron is not in the form of major component, that is called non-ferrous alloy. Example, aluminum alloy. Then next there are some examples are given uh, because we have learned about three important metals in this lesson, that is copper, aluminum, iron. So what are the some alloys are formed? These copper and aluminum iron, whether it is ferrous or non-ferrous, all these are given in this small tabular column. Then first one, see copper alloys, which is a non-ferrous alloy. That means iron is not a major component. So in this brass, first one, brass, copper and zinc, these are the two important components. And what are the uses of this brass alloy? Electrical fitting, metal, decorative items, hardware. These things are manufactured using square brass. Then bronze. What are the element present in bronze? Copper and tin. Cu means copper, Sn means tin. What do they use? Statue. We have seen so many statues are there in the street. So these statues are sometimes made up of stone also, and some statues are made up of bronze. And this is also used to manufacture coins, bell, gongs. Then aluminum alloy, also non-ferrous alloy, and duralumin. And duralumin, aluminium, magnesium, manganese, copper. These are the four important elements. Uses aircraft parts. Aeroplane parts can be manufactured because these alloys are going to be light in weight. Their weight is very very less. So aircraft parts are going to be prepared, and tools, pressure cooker, these things are manufactured. Then magnesium, aluminum and magnesium, these are the two important components in the magnesium. This is also light in weight because of the presence of aluminum is a major proportion. So this also used to prepare aircraft for scientific instruments are manufactured using the alloy of magnesium. Then iron alloy, this is a ferrous alloy because in iron alloy, iron is going to occupy the major proportion. So stainless steel. So what are the components? Iron, carbon, nickel, chromium. So in the manufacture of stainless steel, the carbon non-metal also used. Iron, nickel, chromium are metals. Carbon is a non-metal. The non-metal also mixed to prepare stainless steel. So stainless steel is used in our manufacture of in the kitchen items. For example, utensils, cutlery items, spoon and knife. Automobile parts are manufactured using stainless steel. The nickel steel is also ferrous alloy, iron, carbon and nickel, and uses cable, aircraft parts and propellers. These propellers are used in the ship and boats. These things are manufactured using nickel steel. Then next one, corrosion. What is called corrosion? Corrosion is nothing but this is a gradual destruction of metal by chemical or electrochemical reaction with the environment. So it is the gradual destruction of metal by chemical or electrochemical reaction with the environment. The destruction means nothing but this is the action of damaging the metal, damaging the nature of metal. That is called a destruction by the chemical reaction or electrochemical reaction which are take place in the nature by the environment. So it is a natural process which converts a metal into oxide or hydroxide or sulfide. So it loses its metallic characteristics. So the metallic nature is going to be lost because of the formation of oxide, hydroxide, sulfide. When these elements are going to combine with the carbon dioxide, oxygen, water, this type of corrosions are takes place. So we are going to study about that rusting. So rusting is nothing but it is a chemical process. It is a destruction of iron, gradual destruction of iron by electrochemical reaction. And see here, rust is a chemically known as hydrated ferric oxide. Hydrated ferric oxide. Hydrated ferric oxide is the chemical name of rust, and its formula is Fe2O3 XH2O. Fe2O3 XH2O. That is the formula of rust. And this process of formation of rust is called rusting. The phenomenon of or formation of rust is known as rusting. So rusting result in the formation of a scaling reddish brown hydrated ferric oxide on the surface of iron and iron containing material. So when any iron materials are in the outside or inside, or when it is not in use for a long time, these iron materials get contact with the oxygen, water and carbon dioxide. So these are the three important elements for the destruction of iron: oxygen, water and carbon dioxide. Slowly damage the iron metal and turn to uh, rust, hydrated ferric oxide. Here one diagram is given in 8.12. So how this rust is formed. See the iron rod, the iron material itself acts as two type of electrode. Two type of electrodes are developed itself. One portion is act as cathode, another portion act as anode. Because of this moisture, because of this moisture. So the moisture only give or form cathode and anode in the iron. So at cathode, this oxygen react with the water vapor, and by the gain of 4 electron, hydroxide is formed. Hydroxide, OH minus means hydroxide. And this oxygen further plus 4H plus means that is the gain of hydrogen proton and plus electron. Water molecule is formed. Water molecule is formed in the cathode. And what is take place in the anode? The anode, iron, the atom of iron going to be ion, that is Fe2 plus, by losing 2 electron. So two types of electrodes are developed itself because of the contact of water vapor and air to the iron material. So because of this gain and loss of electron, hydrated ferric oxide Fe2O3 and XH2O is formed, and which is going to be a brownish layer, a brownish or reddish brown layer is formed on the surface of iron metal. Then types of corrosion. There are two types of corrosion. First one is dry corrosion or chemical corrosion. The corrosive action in the absence of moisture is called dry corrosion. Suppose the distraction takes place in the absence of water vapor, in the absence of moisture, water molecule, that is called dry corrosion. So it is the process of chemical attack on a metal by the corrosive liquids or gases like oxygen, nitrogen, sulfur dioxide, hydrogen sulfide. So these gases or liquids get contact with the metal and corrode slowly. This is called dry corrosion, and it occurs at high temperature. Of all the gases given above, oxygen is the most reactive gas to impart the chemical attack. So oxygen is very important element for the destruction of metal. If oxygen contact is no means that chemical destruction will not take place. Then next one, wet corrosion or electrochemical corrosion. So this is the corrosive action in the presence of moisture, in the presence of water, in the presence of H2O. So that is called wet corrosion. The corrosive action in the presence of moisture is called wet corrosion. So this is take place because of electrochemical reaction of metal with water or aqueous solution of salt or acid or bases. So here electrochemical reaction take place. So when water is get contacted, electrochemical reaction take place. Then next one, this is also an important topic, methods of preventing corrosion. How will you prevent, how will you minimize corrosion, how will you minimize the destruction of metal, what are the steps to be taken, what are the methods to be followed. So here few steps are given. First one, alloying. Alloying is the best method to prevent corrosion. So the metals can be alloyed to prevent the process of corrosion. Example, stainless steel. Stainless steel we use in our houses in the form of vessels, tumbler, glass, plate. So these things are not easily corrode because it is alloyed. It is alloyed with the carbon, nickel. So iron is alloyed with the carbon and nickel, and also this is chromium. So iron, carbon, nickel, chromium are used in the stainless steel. So this type of alloying will not easily get contact with the oxygen to distract the metal. Then next see surface coating. So it involves the application of protective coating over the metal. So on the surface some other element is coated to protect the inner element. So it involves application of protective coating. For example, galvanization. That is the process of coating zinc on iron. You have to underline coating zinc on iron. So zinc is coated, zinc is pasted or painted on the iron rod, because zinc is highly reactive than iron. So when oxygen or carbon dioxide or water vapor get contact, zinc only slowly going to corrode, will not allow the oxygen carbon dioxide to get contact with iron. So iron will be saved from corrosion. Then electroplating. It is a method of coating one metal over another metal by passing electric current. So this electroplating is normally used in the cheap jewelry like gold covering. The gold covering ornaments are prepared using this type of electroplating. So in the gold covering ornament, the inside is a cheaper metal, outside is going to be a copper coating or silver coating, gold coatings are given. So this is also a type of a process to minimize corrosion, and also it helps to beautify the manufacture of new articles. Then anodizing. It is an electrochemical process that converts the metal surface into a decorative, durable and corrosion resistant. Aluminum is widely used for anodizing process. So this is the process based on the electrochemical reaction. So it going to convert the surface of metal highly decorative, and for long time it will be corrosion resistant. So for this process aluminum is used. Then cathodic protection. This is the method of controlling corrosion of metal surface. Protected is coated with the metal is easily corrodable. The easily corrodable metal is called sacrificial metal to act as anode, ensuring cathodic protection. You can normally see the cathodic protection magnesium is used because magnesium is highly corrosive, highly reactive than iron and other element. So when magnesium is coated, magnesium only going to react with oxygen, carbon dioxide by saving the element which is inside. So magnesium is act as a sacrificial metal to protect the element, protect the inner element. So this type of protection is called cathodic protection. Then one example is given here. See the in our India, see Pamban Bridge. It is a railway bridge which connects the town of Rameswaram on Pamban Island to mainland India. It is opened on 1914. It was India's first sea bridge in India until the opening of the Bandra-Worli Sea Link in 2010. So we can control the corrosion and renovation of historical Pompan Bridge by a periodical protective coating, which will be the strong example for applied chemistry to uphold our history. So, a bridge is the that is a very fine example of applied chemistry to protect the Pompan Bridge using periodic protective coating. Periodically, they are coating the bridge using the elements, using the protective layer. So this is one fine example of that is protection for preventing corrosion. So, my dear students, up to this second lesson, periodic classification is over, and the next class we are going to discuss about the textbook evaluation, the choose and also choose the best answer is given. Fill in the blanks, match true or false. We are going to discuss in the next class. Send you out write classwork in your classwork. Normally a short answer, long answer, hard questions, and problems. These things you have to write in your uh, classwork. You can keep a separate classwork, or in the same classwork of writing physics also you can write from back side onwards. But you have to write classwork. In classwork, you have to write the topic of the lesson and the short answer, all the short answer, question and answer, long answer, question and answer, and hard question and answer, and if problems given, problem I have to write and write the solution. And classwork is very important. Based on the classwork, you have to prepare well. You have to revise your the lessons. The first lesson, atomic structure. This lesson also you have to prepare well. So we will discuss about the answers textbook evaluation in the next section. So prepare well, be safe at home, and don't be lazy in the learning process. Thank you. God bless you.